GCSE question of the week, week 21. Adam is writing 720 as a product of its prime factors. He writes his answer in index form. 720 equals a to the 4 times b to the power of 2 times c. Find the values of a and b and c. Okay, so this is a write a number as the product of its prime factors question in disguise. Right, we've really just got to do that for a start. Okay, just like if it had said write 720 as the product of its prime factors. Okay, we know what we do then. We do our factor tree type diagram. We'd identify a factor, let's say 2. Okay, we'd have, well, what goes here? 360. 2 times 360 makes 320. 2 is prime. 360 is not. We can keep going. We'll have 180. 2 is prime. We can keep going. 2 is prime. 90 is not. We can keep going. Right, we've got lots of choices here. Let's go for 9 and 10. Okay, neither are prime. 9 breaks down to 3 and 3, both prime. 3 times 3. 10. 2 times 5, both prime. So 720 as the product of its prime factors is 2 times 2 times 2 times 2. We've got 1, 2, 3, 4 2's, 2 times 2 times 2 times 2, or 2 to the power of 4, times 3 times 3, 2 of those, 1 here, 1 here, 3 times 3, or 3 squared, times 5, just 1 5 down here. So if we compare that to what Adam's written, we've got a to the power of 4 times b to the power of 2 times c. And if we match that up with what we've got here, then it should be clear that a is equal to 2, and b is equal to 3, and c is 5. Okay, so we found our values. A is 2, b is 3, and c is 5. Here is another number, q. It's written as the product of its prime factors. Q equals 2 squared times 3 times 5 cubed times 11. Find the highest common factor of 720 and q. So what we're really doing here is we're saying that, well, q's got 2 squared. It's got a factor of 2 squared. And 720 has got a factor of 2 to the power of 4. So what's the highest product of 2's, if you like, that I can take out both of those numbers? Well, it's 2 squared. Now, it might help us to represent this as a Venn diagram, which you're perhaps familiar with doing. Okay, if we put our number q here and our number 720 here, and we compare our two numbers, q has got factors of 2 times 2, 2 squared. So that's a 2 times a 2. 720's got 2 times 2 times 2 times 2. Now only 2 of those we could put in the centre because q was limited by our 2 squared. 3. Okay, q's got a 3 in it, which we can put here. But 720 goes on to 3 times 3, so there's another 3 here. And 5, well, 5 appears as 5 times 5 times 5 in q, but just as 5 in 720. So we can only put 1 5 in the centre, and it's q that's got another factor of 5 times 5, another 2 5's there. Okay, and how do we find out the highest common factor from one of these Venn diagrams? We multiply together all the numbers in that overlap, in the intersection. So our highest common factor is going to be 2 squared, or 2 times 2, times 3, times 5. So 2 times 2 is 4, times 3 is 12, times 5 is 60. So our highest common factor is 60. Alright, so the Venn diagram probably going to help you to do that sort of question, but we could have just spotted q's got 2 squared, 720's got 2 to the power of 4, so we're limited to the 2 squared. Then we could multiply by 3, because we're limited to the 3 in the q. We can't go any higher, there's no higher powers of 3 in the q. And 5 cubed is in q, only 5 in 720, so we're limited to that 5. That'd give us no 11s anywhere. In fact, I should have put an 11, shouldn't I? Outside my... I should have put an 11 there as well, sorry. Didn't matter to our answer, but there should have been 11 there. Can't remember what's just saying. Never mind. Highest common factor 60. Okay, second question. I think both of the questions this week were kind of more overlap questions, no specific foundation or high. Could have been on both. Okay, eggs are packed into 3 different sized boxes, small, medium and large. The number of eggs in each box is shown in the table. Small, 6 eggs, medium, 10 eggs, large, 15 eggs. And Vish has 124 boxes. 35% of the boxes are small, 2/5 medium, and the rest are large. How many eggs does Vish have in total? Okay, well, 35% of the boxes are small. Let's deal with that for a start. So 35% of the boxes, and there are 120 in total. So what do we want to do? We want to know what 35% of 120 is. Okay, and easiest thing to do is change this to our decimal multiplier. That's going to be 35% turned to a decimal, divide by 100, and we know we can turn that of into a times. Always we can turn the of into a times. So we're looking for 0.35 times 120. Okay, let's assume it's a calculator paper. There are plenty of ways we could do it, but 0.35 times 120. We get 42. So there are 42 of the boxes, that isn't it? Yeah, 42 boxes are small. Right, then let's deal with the 2/5 of the boxes are medium. So let's do that bit next. 2/5 of the boxes. Well, we want to know what 2/5 of 120 is. So we could divide 120 by 5 to find 1/5, then multiply by 2. We could times by 2 first, 2 times 120, and then divide by 5. And if it's calculator paper, we can just remember that we want 2/5 times, because the of we can change to times, 2/5 times 120. Right, any of those methods, fine. So we want 2/5. Let's put the 2/5 in first. That's 2/5 times 120. So 48 boxes are medium. Okay. And again, if we didn't have a calculator, we could do 2 times 120, that's 240, then divide by 5. It's the same as dividing by 10, and then doubling our answer. Okay, so 240 divided by 10, that's 24, double our answer, we get 48. The rest are large, so how many are large? Well, 120 boxes. Let's go back to red. 120 boxes. If we take away the number of small boxes plus the number of medium boxes, that's going to tell us how many boxes are large. So we've got 120, take away, I make that 90. That gives me 30 large boxes. How many eggs? Right, so we know how many boxes, then we're just going to find out how many eggs. Well, that's simple enough. We've got 42 small boxes, and in every small box there are 6 eggs. So that's the total number of eggs in the small boxes. Then we've got to add up the number of eggs in the medium boxes. So that's going to be 48 medium boxes, and in every medium box there are 10. That's going to do the mediums. And then we've got to add the number of eggs in the large boxes. So that's 30 times 15. That's done the large boxes. So what's that? Okay, we want 42 times 6. It's 252. And there's no real need to do this in bits, we can do it all in one go. 48 times 10, that's going to be 480. Plus 30 times 15, that's going to be 450. But 30 times 15, 450. So we can add those up in our head, we can do some column addition, or we can do 450 plus 480 plus 252. Total number of eggs are 1182. Okay, so total eggies equals 1182. It was, wasn't it? Yep, 1182. Fantastic, all done. Well done, see you next week.